Let's dive right into this. You know, whenever you're standing on a station platform and a massive freight train or a high-speed express just roars past, it's hard not to think about the sheer inherent danger of these multi-ton metal tubes hurtling around at those speeds. It is completely awe-inspiring. But what keeps those trains from colliding isn't just good brakes. It's an invisible digital nervous system. See, a railway is a vastly complex, holistic system. Various technical subsystems have to interact seamlessly to deliver safe and efficient passenger and freight services. In today's explainer, we're going to unpack exactly how that system works. We'll focus heavily on those critical technical interfaces, where human operation meets digital control, because managing those interfaces is absolutely crucial to preventing operational risks. To understand this whole ecosystem, we're going to take a macro to micro journey. First, we'll look at the control center brain, then signalers and interlocking. After that, tracking with train describers, and finally, informing the passengers.
All right, starting with number 1, the control center brain.
The railway control system is the absolute primary interface for the human operators managing the service. And there's been a massive evolution in how this control is handled. Historically, this meant heavy, physical, mechanical lever frames. Moving points and setting signals literally required serious upper body strength. But today, we've moved to modern computer workstation interfaces. Today's signalers are orchestrating the movements of dozens of trains using keyboards, tracker balls, and these glowing, dynamically updated schematic screens.
Now, while the tech has obviously shifted drastically, going from mechanical restraints and switches to beautifully color-coded software and dynamically reconfigurable screens, the fundamental goal remains exactly the same. The whole point of these interfaces is to give the operator a complete, unambiguous view so they can manage train movements safely. It's really all about giving the human brain the precise inputs it needs to orchestrate what is essentially a massive moving puzzle. Moving on to part 2, signalers and interlocking. So how do those human commands actually translate into the real world? Let's look at the literal synapses of our railway nervous system, the critical interaction between the signaler and the interlocking. Basically, every single command to move a train has to follow a strict, completely non-negotiable loop. The signaler inputs a route instruction at the workstation, but that instruction doesn't just go straight out to the track. No, it goes to the interlocking. The interlocking acts as an absolute safety reflex. It cross-examines the request, checking it against the current state of the tracks. Only when it verifies all safety conditions, guaranteeing there are zero conflicting routes, does it actually allow the trackside infrastructure to move. And crucially, it then feeds that new reality back to the signaler's display as an indication, so they know it happened. If you think about the system architecture, the interlocking is the ultimate safeguard. It sits directly between the human up in the control center and the physical trackside equipment out in the real world. If a human operator accidentally asks to move a set of points while a train is literally passing over them, the interlocking strictly rejects the request. It won't happen. It is the uncompromising, vital safety layer of the entire railway. And to help humans avoid making those unsafe requests in the first place, the interface has its own built-in safeguards. Back in the day, a signaler might place a heavy metal collar over a physical lever just to remind themselves not to pull it, maybe to protect track workers in a specific area. Well, the interlocking now uses a strict software highlight on the screen to do the exact same thing. It actively rejects accidental clicks on restricted areas. It's the exact same safety philosophy, just perfectly translated into digital logic. All right, let's jump to section 3, tracking with train describers. So we have safe routes, but how does the system know exactly which train is actually out there on the tracks? Enter the train describer system and something called a headcode. Every single train operating on the network is given a unique alphanumeric identity. You can think of it as the digital DNA of that specific train journey. It combines the train type, destination, and operator. This headcode is exactly what allows the signaler to identify the train and route it correctly according to the daily timetable.
On a modern display, you'll see a white alphanumeric code sitting right on the red track line, something like 2B06. That's the head code. The train describer system actively moves that identity across the screen from one virtual berth to the next, precisely as the track circuits out in the real world report that the physical train is occupying that specific section of track. Now, the really crucial point here is this. Conventional trains on these lines don't actually broadcast a data signal saying, hey, I'm train 2B06 and I'm right here. Instead, the system cleverly tracks the train's footprints. The describer knows where the train started, and as the sequence of track sections lights up red on the map, the train describer software automatically pushes the headcode along the digital map, one berth at a time. It's basically a highly advanced automated game of digital follow the leader.
Which brings us to a really fascinating question, one that connects this highly secure, invisible control room directly to your daily life. How exactly does the station board know your morning commute is delayed?
Let's answer that in our final section, informing the passengers.
This is all about the outward voice of the railway, specifically the passenger information and public address systems. If you go back a few decades, passenger information meant those giant, mechanical flap displays. They were visually iconic, for sure, but they were super inflexible, slow to update, and totally isolated from actual train movements. Today, we've moved to responsive LED and LCD displays alongside automated audio announcements. And the real magic here isn't just the screens themselves, it's what feeds them. They are directly wired into the heartbeat of the railway. Remember that train describer we just talked about? The system pushing headcode 2B06 from berth to berth? Well, the real-time inputs driving those station announcements and your mobile travel apps are pulled straight from that train describer, which is then cross-referenced with the timetable. That means the exact same nervous system, the interfaces keeping the train safely routed and separated, is what feeds your passenger convenience. It is one massive, seamlessly interacting, holistic system. So the next time you glance up at a platform display and hear an automated announcement telling you your train is approaching, I really want you to think about this explainer. Take a moment to marvel at the vast web of human operators mapping out routes and those rigid digital interlockings working flawlessly behind the curtain to reject danger. Just ask yourself, how many thousands of invisible digital handshakes had to happen flawlessly in real time just to safely get you to work today? It's genuinely incredible. Thanks so much for joining me on this deep dive, and keep asking questions about the hidden systems around you.